Okay, so in the last video we had discussed the compiler, assembler, linker, loader and how they work collectively to make the executable from a user written source program. We had also created a simple password authenticator in C language and converted it into an executable file by compiling, assembling and linking it with library files separately. And that executable was working fine, but at the end of the program it was showing the segmentation fault. So today in this video we'll try to find out why that segmentation fault has occurred, and the program or the tool that we will use for this is GDB, the GNU debugger. It is an open source and very popular debugger, and it comes by default with Linux platform. So let's open this file in GDB. Now let's first see what are the different functions that are present in this file, and to do that we can use the info command. So type info and function, and remember you can also use the tab completion here. So here we have functions such as string compare, printf, our main function, etc. Now let me compile our original C program using GCC compiler for 32-bit architecture. And now if we check the available function in this file, we can clearly see that this new executable has some extra functions such as start, init, fini, etc. And if we check the entry point address of this new executable using info file command, we found that it is set to 1090, which is the address of this start function. So basically what happens is, when we run any C executable, it starts the execution from this start function, and the main job of this start function is to call the libc start main function, and after that the libc start main function calls the init function which does some initialization, then it calls the main function, and at the last, after executing the main, it calls the fini function which does some cleanup, and at the end it also calls the exit function to exit the program smoothly without any error. One thing to observe here is that right now we don't have the exit function here, and the reason for that is the dynamic linking. In dynamic linking, some shared object files are included when we start the execution of the program. Therefore, if we do info function after starting the execution, we'll see that some extra functions have been added along with the exit function. Now let's observe our old program. So here the entry point address is our main function instead of this start function. So now let's find out what happens at the end of the execution. And to do that, let's first disassemble the main and make a breakpoint at exit of main, and then run the program. So now we are at this return instruction, which will exit the main and will take us to the address pointed by stack pointer. And right now the top of the stack pointer is having the value 1, and therefore if we execute the next instruction, the program will try to access this memory location which is outside the scope of our program, and as a result it shows the segmentation fault. In short, it is indicating that we are not terminating the execution properly by calling the exit function. Now the question is why these functions are not included in our program, and the answer is that in last video while linking the library files we had used one E option to set the entry point address as the main symbol instead of this start symbol, which calls the libc start main and which in turn calls the exit function. So let's try to add this start symbol as the entry point of our program. Okay, so it is showing the error that it is not able to find the start symbol, and this happened because the start symbol doesn't come from the standard C library, but instead it comes from some other shared object file. So now what we can do is we can just see the libraries and object file added by GCC compiler using verbose option. So here we can see that the collect2 is linking some extra object file, and these are the object file which contains the information about start, init and fin function. Okay, so now let's link all these object file in our old object file that we have generated in the last video. And now if we execute the program, we can see that it is executing fine without any segmentation fault. And we can also verify it with GDB that now it has all the functions such as start, init, fini, etc. Okay, so that is all for this video. I hope this has helped you a little bit, and in the next video we'll try to crack this password authenticator using GDB. Till then, keep exploring, keep growing. See you.